Every morning, millions of eggshells meet the same fate. Globally, we produce almost 8.3 million tons of solid waste every year, which is almost 23,000 tons of solid waste per every day. In Bangladesh, the number is almost doubled, which is almost equal to 47,000 tons of solid waste per day.
Meanwhile, industries rely on expensive, non-renewable and sometimes toxic catalysts to make chemicals, fuels and our everyday products. These hidden villains silently poison our environment every day.
What if we could tackle both the problems at once? Because inside every eggshell, there is something extraordinary. Calcium carbonate, the perfect starting point to create hydroxyapatite.
Hydroxyapatite is a naturally occurring calcium and phosphate mineral. It is widely available in teeth and bones. Its high surface area and porous structure provides ample active sites for effective catalysis.
It has also some diverse applications, such as surface treatment, separation and purification, energy storage, and biomedical uses.
First, the eggshells are thoroughly washed with water to remove impurities. They are then placed on a tray and dried in a hot air oven at around 80 degrees Celsius. After drying, the shells are ground into a fine powder. The powder is then heated in a furnace at 900 degrees Celsius to obtain a stable calcium oxide source. Once cooled, the powder is mixed with distilled water to form a slurry. Phosphoric acid is then added to the slurry. To maintain a basic pH, ammonium hydroxide is introduced. The mixture is continuously stirred using a magnetic stirrer. After stirring, the precipitate is separated using a vacuum filtration system with filter paper. The collected solid is dried again in an oven at 80 degrees Celsius to remove moisture. This is the desired hydroxyapatite powder.
Now, let's take a look at the structure of our protagonist, hydroxyapatite. Both the crystalline and molecular structure are shown here. Let's take a deep look at the molecular structure. It has abundant calcium, phosphate and hydroxy layers. These calcium ions are very good Lewis acid sites. On the other hand, hydroxyl ions are very good basic sites. Let's see hydroxyapatite in action. This is triglyceride. Its partner in crime is methanol. When they are reacted in the presence of HAP, they produce a mixture of fatty esters. This is in fact the biodiesel production by transesterification. In fact, it is done in most industries using conventional catalysts like sodium hydroxide. But why one should use HAP instead of sodium hydroxide? Well, let's look at this chart. Sodium hydroxide is much more cheaper than hydroxyapatite. However, it is much more toxic. Moreover, sodium hydroxide is not as reusable as hydroxyapatite. To show its reusability, we can look at the transmission electron microscopy images. Here we can see, even after spending 5% copper HAP catalyst, the amount is available for reuse again. This just demonstrates the diverse potential of hydroxyapatite in varied industries.
The circular economy of hydroxyapatite challenges the wasteful linear model of take, make and dispose.
Instead, it recycles and upcycles eggshell, reducing both environmental impact and raw material cost.
By using everyday ingredients like eggshells in industries can save money while creating sustainable values. So, don't throw it away. Let the shells pave the way.